Hello, everyone. This video is going to cover 3.3 dividing polynomials. If you remember in 3.2, we looked at how to graph higher degree polynomials. And if you remember, we looked at end behavior, but we also looked at the zeros, which are the x-intercepts, in order to graph those higher degree polynomials. If you noticed, all of those problems were easily factorable. Okay, so we're going to be taking a look at how to graph these higher degree polynomials, not here in 3.3, but in 3.4. And what happens is when it's not factorable, we try to get it at least to the point where it can be factorable if we do some division beforehand. Okay, so that's why here in 3.3 we're going to look at long division and synthetic division with higher degree polynomials. Okay, so 3.3, dividing polynomials. The process is very similar to dividing numbers, doing long division with numbers. Okay, so one thing you want to make sure is to arrange both polynomials in what we call descending order. This means we are putting it in order, starting with the largest exponent first. Okay, so something that looks like this. So maybe you have 3x cubed minus 5x squared plus 7x minus 1. Okay, so we see here the exponents go in order. We have a power 3, and then a power 2, a power 1, and then 0 power. Okay, so this is not what we want. So maybe you have 5x, and then you have plus 7, and then minus 2x squared, and then minus 4x cubed. Okay, so here this is not in descending order. So if we want to put this in descending order, we start with the largest exponent here, which is 3, and then we would go to 2, and then we would do this here, and then the constant. Okay, so it would be negative 4x cubed minus 2x squared plus 5x minus 7. Okay, the other thing you want to do is also use a placeholder zero for any missing terms. So for example, if you have something like this, 5x cubed minus 2x plus 7. Okay, so if you have something like this, it is in descending order. However, we are missing the x squared term. Okay, so we would make sure to use a placeholder right here for the x squared term that is missing, and then bring everything else. Okay, if you're missing 2 terms, then you have 2 placeholders. Okay. Okay, so like I was saying, long division here with polynomials, the process is very similar to doing long division with numbers. So depending on how you learned, it may be different from the way I learned. Okay, so long division is actually taught differently in different countries. Okay, so I'm going to skip long division with numbers, and I'm going to jump right into long division with polynomials. Okay, suppose that I want to do this long division problem. Okay, suppose that I am going to divide by x minus 4, and I will be dividing that into 6x squared minus 26x plus 12. Okay, so what happens here is just like long division, you're trying to figure out what times what will give you this inside here. So when you're trying to figure out what should go here, you will be looking at this here, but at first you're going to ignore that the rest of the polynomial, you're only going to use the leading term, okay, x. So you ask yourself, well, x times what, okay, x times what will give me 6x squared, okay? X times what will give me 6x squared? So that would have to be 6x. X times 6x will give you the 6x squared, okay? All right, so once you figure out this number here up, this term on top, now we can go ahead and bring back that minus 4, okay? So what we do now is we distribute the 6x that we wrote on top. We distribute that to the x minus 4. So 6x times x is 6x squared. 6x times negative 4 is negative 24x. Okay? And just like regular long division, we're going to go ahead and subtract this. Okay? So 6x squared minus 6x squared cancels out. This here double negative becomes positive 24x. Positive 24x and negative 26x is going to give us negative 2x. Okay, and then I'm going to bring down this plus 12, just like in long division. And then I repeat the process. Okay, so again, I could ignore the minus 4 for now when I'm trying to decide what is going to go up here. Okay, so I just use that leading term x, and I ask myself, x times what will give me the negative 2x? So it should be negative 2. Okay, so let's bring that minus 4 back, and let's distribute the negative 2 to the x minus 4. So negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. Okay, and then we're going to go ahead and subtract. So that becomes negative 8. So negative 8 and positive 12 is 4. Okay, so this here is my remainder. So when we write our remainders, we take its sign, which is positive, okay? And we write it over the thing we're dividing by, x minus 4. Okay, so the final answer here is going to be 6x minus 2 plus 4 over x minus 4. That would be the final answer. Okay, so you might come across some homework problems that say, oh, write the function as a product and a sum. So let me show you what that means. So they might ask you to write your polynomial as a product of two polynomials plus another one. I'll tell you what each of these represents. So this polynomial p of x is the one that's on the inside, okay? So this is your dividend. Okay, this is the one that's on the inside. So we see here, it's the one that's on the inside there. Okay. The d of x is your divisor. Okay, this is the one that's on the outside. Okay, so that would be the x minus 4, this one right here. That's your divisor. Okay, and the quotient is going to be your answer without the remainder, and this r is going to be your remainder. Okay, so the quotient is the answer that you get on top. So it's your answer without the remainder. And then here it's just your remainder, which is 4, not the fraction up here, but just the remainder 4. Okay. So it's without the denominator. Okay, so if we were to rewrite p of x up here, the example, 6x squared minus 26x plus 12. That should equal to the one on the outside, which is x minus 4, times your quotient, which is your answer without the remainder, so 6x minus 2, plus your remainder, which is 4. If your remainder were negative, then you would take the negative. Okay, so I don't think I will have these on the test, but it might be in your homework, okay? Just this, being able to do the long division, that's what I'll expect from you on the test. Okay, so let's take a look at another example. Let's go ahead and find negative 7x squared plus 5 plus 2x cubed divided by x minus 3. Okay, so x minus 3 on the outside, and the other one will go on the inside. Let's go ahead and put it in descending order, and let's use some placeholders if we need to. So if we place this in descending order, the first term will have to be 2x cubed. And then the next term will be negative 7x squared. And then we are missing the x term, so we're going to use the placeholder 0x and then plus 5. Okay, so again, to figure out this number, we're going to go ahead and ignore the minus 3 to try to guess that number that goes in there. Okay, so x times what is 2x cubed? So x times 2x squared. Okay, so let's go ahead and bring that minus 3 back in. And now let's go ahead and distribute that 2x squared. So 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Okay, and then I'm going to subtract this. Okay, so 2x cubed minus 2x cubed cancels out. Negative 6 becomes positive 6x squared. So positive 6x squared minus 7x squared is negative x squared. Okay, so let's go ahead and bring this down. Okay, so again, ignore the -3 portion of this and ask yourself, x times what will give you negative x squared? Okay, x times what will give you negative x squared? So x times negative x. Okay, so let's go ahead and bring back that -3 here. And let's distribute negative x to x minus 3. So negative x times x is negative x squared. Negative x times 3 is positive 3x. Okay, and we're going to go ahead and subtract this. These cancel out. We end up with negative 3x plus 0x is negative 3x. And I will bring down the plus 5. And again, using just the leading term x, ignoring the -3 part, x times what is negative 3x? So x times negative 3. Okay, let's go ahead and distribute that -3. So I get negative 3x, and negative 3 times negative 3 is plus 9. Okay, so let's subtract this. These guys cancel. That becomes a negative 9 plus 5, which is negative 4. Okay, and that's our remainder. So we write it up here, negative 4 over what we're dividing by, which is x minus 3. Okay, so that's our answer, 2x squared minus x minus 3 minus 4 over x minus 3. Okay, so that's long division. That's one of the two types of division we're going to look at here today in 3.3. So let me show you synthetic division. So synthetic division, so you definitely want to arrange it in descending order as well. Okay, and you also want to make sure that you use the 0 placeholder for missing terms. And it turns out you can only use synthetic division if you're dividing by x plus a number or x minus a number. Okay, so if you have x squared plus 3, nope, you can't use it. Okay, if you have x squared plus 2x minus 1, you can't use it. If you have 2x minus 5, you can't use it. Okay, all right, so it has to be strictly x, 1x, plus or minus a number. Okay, so 1x plus or minus a number. Okay, so let's take a look at this example. Okay, which is going to be the one that we just did with long division. So you can see the difference between the two types. Okay, so we already did this problem using long division. So I'm going to show you how to do the same problem using synthetic division. Okay. Okay, so first of all, right over here, if I take this and set it equal to 0 and solve it, I get x equals 3, right? You add 3 to both sides. So you get x equals 3. Okay, so what happens here is you're going to have a line. On the left side of the line, you're going to have that x equals 3. On the other side of the line, you're going to use the coefficients of this polynomial, and you're going to use 0 for any missing terms. So I'm going to use the 2. Again, just the coefficients. -7. I'm missing the x term, so I'll put a 0. And then 5. Okay? Now leave some space below those numbers and then draw a line. So leave space and then draw a line. Okay, so the first thing you do is you always bring down this first number, no matter what it is. Okay? And then I'm going to go ahead and fill this row with numbers. And the way I get that row is by multiplying. Okay, so what do I multiply? Well, for here, I'm going to do 2 times 3. Okay, so that's going to give me 6. Okay, so I have the first number there. And what happens is I'm also going to fill this row with numbers. And the way I get these numbers is by combining. What do I combine? These two right here. Okay, so -7 plus 6 is -1. Okay, and then I repeat that process. So I'm going to get the number next to 6. I'm going to get that by multiplying. So I'm going to multiply -1 times the outside number is -3. And then I'm going to combine these. 0 and -3 gives me -3. And then I'm going to multiply again. -3 times the outside number. -3 times 3 is -9. And then I'm going to combine these. 5 and -9 is -4. Okay. And so what happens is you end up with these numbers, 2, -1, -3, -4. And it turns out this number here at the very end is always your remainder. And if you look back to here, we see that the remainder here is -4. Okay. So that last number is always the remainder. And these guys here are your coefficients of your answer. Okay. And it's always 1 degree less than whatever you start with. So right over here, this here is a degree 3. Okay, I can see right there. Okay, so it's a degree 3. So down here, this is going to be a degree 2 polynomial. Okay, so that's going to be 2x squared minus 1x minus 3. And that last bit is our remainder. And we always put it over what we're dividing by. And we're dividing by x minus 3. Okay, and you'll see this is exactly the same answer that we got when we did long division. Here it is. 2x squared minus x minus 3 minus 4 over x minus 3, which is exactly what we got here. Okay? All right, so I kind of worked that out step by step. So let's go ahead and take a look at another one. Okay, so suppose that we are dividing this. X cubed minus 8x plus 2 divided by x plus 3. Okay, so again, right here, x plus 3 equals 0, so x equals negative 3 is what we're using. So we're using x equals negative 3. And then we'll put the coefficients of this polynomial over here and use 0 for any missing terms. So it's in descending order, so we're good. We're going to have 1. We're missing x squared, so let's go ahead and put a 0. And then negative 8, and then positive 2. Okay, those are just the coefficients of this polynomial. Okay, all right, leave some space and draw a line. Bring down this first number, 1. And we begin to multiply and then combine. Multiply, combine, multiply, combine. Okay, so multiplying 1 times negative 3, I get negative 3. Combining 0 and negative 3, I get negative 3. And repeat the process. So negative 3 times negative 3, that's positive 9. Okay, and then when we combine this, we get 1. Okay, and then multiply again, and we get negative 3. And when we combine these, we get negative 1. Okay, and this is a degree 3. So this will be a degree 2, always 1 degree less. Okay, so it's going to be 1x squared minus 3x plus 1 minus our remainder, so minus 1 over x plus 3. Okay, see how we got this? Okay. All right, so just remember, you start here, you bring down this 1, okay, and then you multiply. Multiply, and you get this negative 3. And then combine to get this negative 3. And then multiply to get the 9, and then combine. And then multiply, and then combine. Okay? Okay. Again, if you have any questions, just email me or text me through the Remind app. Okay? Okay, so we have something called the Remainder Theorem. Okay, so this will most likely be on the test. So this here states that if polynomial p of x is divided by x minus c, then the remainder, that last number that you get when you do synthetic division, that's your remainder. The remainder is the value of p of c. Okay, so let me show you what that means. Do you remember when we were evaluating functions, like you had a function and it said, okay, well, find f of 2. So you would take that 2, plug it into the function, replace all the x's with 2, and then work it out, right? So that's how you would evaluate it. So what this remainder theorem is saying is that this is another way you can evaluate it. You can evaluate the function by doing the synthetic division, and the remainder will be equivalent to the answer that you get when you plug in 2 or whatever the number is. Okay, so let's take a look. Use the remainder theorem to find p of -2 for this function. P of x equals 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. Okay, so a really long function here, and it would be kind of a pain to plug in -2 into all of those x's and work them out if I didn't have a calculator, right? So instead of replacing all those x's with -2, what you can do is do synthetic division for x equals -2. So 3, 5, -4, 0 placeholder because x squared is missing, 7, and 3. Okay, so let's go ahead and do the long division. And according to the remainder theorem, whatever I end up with over here for my remainder, that's going to be my answer. So I don't have to plug in -2 into that function and work it all out. I can do the synthetic division, and whatever I get for the remainder, that's my answer. That's equivalent to plugging in to whatever you get when you plug in -2. Okay, all right, so bring this down. And then multiply. 3 times -2 is -6. And then combine. 5 and -6 is -1. And then multiply again. -1 times -2 is +2. And then combine. -4 and +2 is -2. And then multiply. -2 times -2 is 4. And then combine. 0 and 4 is 4. And then multiply again. 4 times -2 is -8. And then combine. 7 and -8 is -1. And then multiply one more time. -1 times -2 is 2. And then when you combine this, it is 5. Therefore, P of -2 equals 5. Okay. Okay, so what's going to happen here is in the next chapter, we're going to be using this because just like with real numbers, if you're doing long division, right? Like let's say 125 divided by 5. If we have a remainder of 0, waiting for it. If we have a remainder of 0, then that means that this number inside 125 is divisible by 5. So then that means that I can rewrite 125 as 5 times something else, right? And not have a remainder. So we're going to be using that idea in the next section to factor. So what's going to happen is we might start off with something that is not factorable, okay? And then we are going to do this synthetic division business until we get zero remainder. And if we get a zero remainder, then that means that this here is a 0 or an x-intercept, right? And if that's the case, then hopefully we'll be able to factor that part, okay? So what we're going to be doing here is when higher degree polynomials are not factorable, we try to get it down to a degree 2 or down to a polynomial here that is factorable. But in order for us to get there, we're going to have to do some work using the synthetic division until we get a 0 here. Okay, so that's what we're going to be aiming for in 3.4. Okay, all right, so again, if you have any questions, make sure you email me or you text me. If you want me to meet with you on Zoom to go over some of this, just let me know, okay? Or if you want me to make a video of any particular part of this, I can do that as well, okay? All right, make sure you're keeping up with the homework. I'll see you next time.